Logarithmic functions. So today is really just a review of our Algebra 2, the basics of logarithms and exponential functions. A to the y equals x. That's just an exponential function. We just got done doing a whole bunch of. And the logarithm function looks like that. Logarithms are nothing more than dealing with exponents. So that's why we cover this after we talk about exponential functions. So these two are the same thing. Here's what you were taught. The base raised to that power equals that. A to the y equals x. A little history for you in your book. If you want to read that, go right ahead. That's where it all came from. Okay? Now, having said that, we're going to go over kind of going back and forth between the two and just kind of reviewing what some of the shortcuts were that you were taught. So here's some properties, aka shortcuts, that you were taught in Algebra 2. So log base A of 1 equals something. Anybody know what the log of 1 is?
0.
Okay. If we put this in exponential form, I'm going to put a to the y equals 1. Transferring this to an exponential form, what must y be for your answer to be 1? What does the exponent have to be for your answer to be 1?
0.
0. Anything with the 0 power is 1. So y equals 0. So this is log base A equals log 1 base A equals 0. Alright, here's another one. Log A of base A equals something. So again, put it in exponential form. Who can put it in exponential form for me? Whatever.
A to the y is equal to A.
A to the y equals A. So what is y?
1.
Yeah, a to the first power is A, isn't it? So y must be 1. So the log of A on base A equals 1. Shortcut, if these are the same. So to look at this a little bit more complex, log of A base A to the x power, and put it in exponential form for me.
How you doing?
I'm doing great. How are you? It's nice to know. Feel loved. Great. Put an exponential form for me. What did we do on each of these? What's the base?
A.
Raised to what power? Equals that whole thing. A to the x. So what's y? X. Y and x must be the same. Y equals x. So what we have here is log of A base A, log of A to the x on base A equals x. So here's the shortcut. If these two are the same, then the exponent goes there. So what was the exponent on this A? It was a 1. That's what the answer is. So that's the shortcut. Your goal, though, is you got to make those two the same, and that's what you're going to get into pretty soon. Now, the last one, A raised to log of x base A equals something. Alright, so this is an exponential form. If I work this backwards, my exponents here are the actual answers. My exponent is the answer. Exponents on this would be the answer if you look at this, a to the y. This exponent is the answer here. So if I rewrite this, this actually is the answer, log of a of x. And my base is still just log of a of x. Watch. A raised to that, right? A raised to this equals this. A raised to this equals that. A raised to this equals that. A raised to this whole thing equals what? X. So the shortcut is, if these are the same, then this is my answer. Alright, so you have to remember those properties. So I'm going to do some problems for you to help you remember what these properties are, okay? Again, you need to practice to put them into memory. Alright. Let's just start with something simple here. Log of 1 of base 6 is what? Look at your properties. Property A, B, C, and D. Which property? Which property are we going to use? A. What's my answer? 0. Good. Property do you use? How about B?
B? Yeah, that's what I said.
C works.
Exactly.
B and C are basically the same. What's your exponent? So your answer is? The key is these have to be the same, alright? Having said that, what's my answer? 2. Now watch what I do here. The answer is still 2. Why?
6 to the second is 36.
6 squared is 36. You have to make these the same. So you be prepared to manipulate these values so that they match your bases. So that answers 2, because that's 6 squared. Okay? 6 raised to the log of 15 base 6. Which property? Property. D, so what's my answer? What's my answer? Yeah, I know. Emily, do you know what the answer is? Lexi, do you know what the answer is?
15.
Yes, Lexi, it's 15. Good job, Lexi. 15. Shortcut. Those are the same. That's the answer. Alright, now let's do some examples. Let's see. Example 8. All I need you to do is convert this from a logarithm to an exponential function. So what you do is you take the base. What is the base? It's not written up there. It is understood that the base is 10 if there's no base written for logs. For natural log, it's e. Hard to learn when you're sitting in the hallway, isn't it? Yeah, I'm looking at you. You're the only voice I hear over there.
I'm the only one trying to participate.
Okay, I appreciate that.
Thank you.
Alright, so the base is 10. So you're going to take the base, raise it to the answer, and it's equal to that number. Aren't they equal? 10 to the negative 1? Is it 10 to the negative 1 the same as 1 over 10? 1 over 10, which is 0.1. Just showing you that they are the same. Okay, part B. Now that you know how to do it, let's do this one. Log 512 base 8 equals 3. Somebody rewrite it in exponential form for me, Vito. Tell me what to write. What's your base? Raised to what power?
500.
You see all these arrows on these other examples? Raised to the third power. What's 8 to the third on your calculator, Vito?
512.
Let's prove it. Alright. The base raised to the answer equals that. Good. Alright, example 12. Let's see if we can do this one. This is part A. The natural log of y equals 5. Who understands what the natural log means? Yes. But this can be written like this. Log base e of y equals 5. So whenever you see natural log, it's the same thing as this. For the most part, what we're talking about.
Is that lowercase l in one?
Yes. Natural log. Backwards. They didn't ask me. Okay, so what is this answer in an exponential form? Destiny. Yes, Destiny. E to the 5th equals y. She was taking too long, alright. Alright, without rewriting it, what's the answer? Destiny. Just because it looks weird doesn't mean you do it differently. Let's let the ladies answer this time. Yep, e to the 4th equals, you said x minus 1? Yeah. And then you could calculate this if you wanted to. You can take e to the 4th on your calculator, then you would add 1 to it and you get your answer. But we're not doing that today. Okay? So that's converting to exponential functions. We all do that, or do I need to get the dry erase boards out and have you all answer questions by yourself? Show me.
That would be a good time. That would actually be good.
Be a good time? Well, I just got a bunch of brand new dry erase boards. They just didn't give me markers or erasers.
We could pass it around.
So,
Could pass it.
I can say we have them. I just can't use them.
So,
Yes.
balls.
Balls. Convert this the other direction. Now you have the exponential function. Put it in logarithmic function form. What is your base? 10. So that's your base in logarithm form. I don't need to write 10. If you don't write the number, it is 10. Okay, what's my exponent?
1,000.
What?
Oh, yeah, it's
3.
1,000. And it equals 3.
1,000.
My exponent's 3,
Which is 3.
Shut up, Davey.
which is what your logarithm equals. It equals the exponent. Right? 10 to the third is 1,000. Okay. Alright, let's do another one. Some of you are hanging on by a thread. Okay, so now I gotta reteach fractional exponents, because the other two classes didn't have any idea what I was talking about. Keep your mouth. Anyway. Watch. The square root of 9 is what?
3.
It's the same thing as 9 to the 1/2. The exponent on your base over the root. Cubed root of 8
2.
is 2. It's the same thing as 8 to the 1 over 3. The fourth root of 4 squared. Ah, smarty. Yes. Fourth root of 16 is 2, which is the same thing as 4. The 2 over 4, which is 4 to the 1/2, which is 2, which is 7. So make sure you understand this. You got to be able to convert this. Okay, for your homework tonight. So you got to be able to do this. All right. So having said that, let's put this in logarithmic form. What's your base? 81. So log base 81. What's my exponent? What is the exponent? Is equal to what? 81 to the 1/2 is 9. That's what that says. Okay, you gotta get proficient at this, okay? So you can check your answer when you're done to see if it works, because you all seem to be fairly comfortable going from logarithmic form to exponential form. Okay.
What was the problem with like the factoring?
What?
Like, what was the problem with the other two classes with the factoring? Like, I don't
No,
see.
they didn't know. They didn't remember this.
Oh, okay.
It's okay. I just showed you again.
Sometimes you start off slow.
Are you thanking me, or
No.
you're not thanking me for showing you
I would be
this?
thinking it.
Oh, thank you. Yeah.
Because this really isn't something that's part of this lesson. You're supposed to already know.
You
Lessons.
know what I'm talking about?
Lesson. I have a passing grade. Do you?
With my parents.
Okay. All right. Example 20. Part A. What's that equal? Raise your hand. Hannah. Look at your properties. What does that equal? Look at your properties. C. Property C. Huh?
Is it okay?
Okay, did you look at it?
Yeah.
What's it say? What's the shortcut?
That's what it says. Right here. Hold on.
This part right here. So the point is, if those two are the same, what's my answer?
X.
Yeah, so what's in that position? Yeah. Done. Everybody has their calculators?
Yep. Minus B. Yeah, we don't.
Alright, just do this for me. Go and hit the button that says math. Arrow down to where it says log something. Log base. Hit enter. Hit math.
Yeah.
Everybody find the math button?
Yeah.
Anybody not find it?
I'm just saying, there's no. There's no.
Oh, arrow all the way down.
Yeah, the bottom is solver dot dot
Oh,
dot.
I'm going.
What?
Yeah, there's no log base on yours.
Go to the catalog.
I just did this earlier.
You say there's a log button?
Yeah, there is a log
Well,
button.
you
Very
were just
good.
going to like get done or something.
Oh my gosh. Alright. For those of you who have a school's calculators, just relax. You don't need it for today. I'll have to take a couple problems out of your homework. But I'll see if I'll figure out where it's at on this calculator, okay? We'll come back to this, okay? B.
Wait there.
Let's write this down. Two's the first is what?
2,
2 squared,
4,
2 cubed.
Hey, what if, we have a button that says log.
Oh my God.
Oh. Sorry, I told you to say it.
I
You
did.
make this stupid all the time.
I'm sorry, but that was so fun.
2 to the 4th,
I thought you were about
2 to the 5th.
64. 128. 56.
3 to the 1st,
Oh, yeah.
3 squared, 3 cubed. 27.
27.
You said 9. 3 to the 4th, 3 to the 5th.
It sounds just like back there.
4 squared, Baylor.
60.
4 cubed, Baylor.
32.
60.
Oh my
60.
God.
64.
You're not.
4 to the 4th.
1656.
4 to the 5th.
Oh, you know.
4 times 200.
1,000.
500.
4 times 200 is 500.
600.
1,024.
Oh my
Do I have anything on here that looks like 64 and 4?
4 to the 3rd.
4 to the 3rd. What's the answer?
4 to 3.
3. Alright, so it's helpful to know your exponents and what they equal so you can manipulate stuff. You also need to make sure you can do this because they aren't all going to be like that. Some of them are going to have radicals and some of them need to be negatives because they're in your denominator. You got to be able to manipulate that stuff. Do you understand the words that are coming out of my mouth? I don't think so. I agree. 26. E to the natural log of pi. I don't know, there's too many squiggly lines up there.
Is A part of the problem?
They have blue ones.
Thank you.
The parentheses up, huh?
That's a big deal.
What's another way of writing natural log?
Log E.
log base e. So if, oops, e to the log base e of I. So property D, the fourth property you have, what's that say? What's my answer?
Pi.
Pi. D. 10 to the log of 5. What?
5.
5. Because this is just base 10 here. Good. Number 32. Part A. I'm keeping you awake. Hmm? Emily, what do you think? Put it in exponential form for me. Anna, can you put it in exponential form for me? I'm sorry? 4 raised to the x equals 2. So what's x have to be? 4 squared is 2. 4 to the 16 is 2.
1/2.
1/2. Why 1/2?
Because then you
No, I
have
was repeating what you said. I was just putting it back in. You said x is 2, and I said, so if x is 2, 4 squared is 2. I was just repeating what you were saying.
Okay.
Alright, so why 1/2?
to gives you 2.
Yeah, isn't 1/2 just a square root? And what's the square root of 4? So x is 1/2. Part B. Log of x base 4 equals 2.
No, it's not that.
Destiny, what is it?
Don't give yourself a concussion.
What? Yeah. 4 squared equals x. So what's x? 16. Did you guys take algebra 2 before you came in here?
A logarithm is, I mean, why does
Well, look, I got a concussion last year and forgot everything I did.
Huh?
I just did. I'm on a court. No,
Alright,
you got a concussion.
let's go back and do a couple more because I'm not convinced. The base has to be the same as the other number. So how do I make 9 into 3?
3 That's 27 now.
Yeah.
3 to the
3
2nd.
squared.
What's the answer, Baylor?
I go with 2.
Yeah. Let's do another one. Oops. 10 raised to the log of 87 equals what?
87.
87. Thank you. All right, let's change some things here. It's example 46. What?
Where did it come from?
What?
That graph.
I'm giving it to you. Here's. What is your problem? You.
Me?
Yeah.
I was just wondering where it came from when you were like, I'm giving it to you. I said, okay.
Given a, let me finish the problem, the setup first, okay? Given the graph of this logarithmic function, okay? And a point that is on the graph, that'd be 1/2, -1. Tell me what the equation was, what the logarithmic function is that made that graph. So your generic logarithmic equation is y equals log of x base a. Well, you have three variables there. You can't solve an equation if you have more than one variable, more than one different kind of variable. So do we know x and y? Any value that is on that line is a solution to this problem. So if y is -1 and x is 1/2, what is a? Put it into exponential form. Okay. Put an exponential form for me. Great. Well, what's a to the -1? How do I change that to a positive exponent?
1 over a. 1 over a.
1 over a equals 1 over 2, so what's a? Yeah, a must be 2. So, if a is 2, then my equation is y equals log of x base 2. That is where that line comes from. Okay? Shall we do another one? Here. We'll do 48. Here's your graph. Tell me the equation. Give me the equation. For what? When? For what?
I shall be I heard his class
Alright, so here's your generic form, y equals log of x base a, y is 2, x is 9, put it in logarithmic or exponential form for me, Shelby. A squared equals 9, so what is a? A must be 3, so my equation is y equals log of x base 3. No, not too bad. Because I gave you all nice, wonderful numbers. So today is really just taking stuff like this with some nice, neat numbers and refreshing your memory on how to deal with the properties of logarithms. Your homework assignment, page 322, 557 odds. I think it's 59. It's 59. Oh, forgot one thing. Alright, this is real quick. Shifting. I don't need to spend any time on this because you all should understand this from the exponential functions. K plus the log of x minus h on base a. Here's you have your h and your k again. It's about shifting. So what do you think the grouping symbols do? Make it move, shift what direction?
Left or right?
Left or right. Alright, so that's left or right. Which, what do you think this is?
Up or down?
Up and down, just like on the other stuff. Alright, that's really all you need.